Hey everyone, and thanks for listening to another episode of DIB Innovators. Today I'm speaking with Zach Shore, Chief Revenue Officer, Hermeus. Zach, this is so exciting. Been fired up to get you guys on the show, so thanks for joining.
Yeah, happy to be here.
Yeah, I know you guys are doing a lot, got a lot of good press. Before we get into it, just give us a background. I mean, your journey in defense tech and finding yourself at Hermeus is cool. Your timing's been great, and obviously you've been performing. So just give us kind of a walkthrough as we shape this conversation going forward.
So my background, originally Marine SIG officer, served tours in Iraq in Fallujah and Ramadi, then transitioned into a TT, a transition team role as an infantryman in Helmand. And so got a very, very unique sort of high-low mix of the warfighting capabilities in the United States. Got out, grad school, did some consulting at Deloitte, some private equity in aerospace and defense, and then really where my career, as we kind of know it now, or it started, was at Anduril back in early 2019, and joined that team, worked for Chris Bros and Matt Steckman on the go-to-market side, and was responsible for the whole Lattice program. So I stood up the command and control business unit for Anduril, which as a SIGINer was like a perfect kind of fit, and then was there for about 3 years, and then came over to Hermeus to lead their go-to-market function and wanted to really get into hardware. I've been solely doing software work at Anduril and wanted to get into hardware work. So joined Hermeus about 3.5 years ago and have been here ever since.
Cool. I was talking a little bit, I think it's fascinating. You're the earliest Anduril guy I've had. I know you were hired pretty early there. What was that like? The experience and seeing them really blow open defense tech for our country.
Yeah, I mean, it was crazy. You go into moments like that and you don't really know what it's going to be. I remember making the decision to join them. I was very excited, but it wasn't like, oh, this thing is going to be huge, or even that was the motivation. It was an exciting seat because coming from private equity in aerospace and defense, it's been a lot of time looking at the traditional model, and it just, we all kind of knew it wasn't working. I also knew that as a service person. But what you really saw that was fascinating was a confluence of the expertise and experience that the founders had, and they've learned at Palantir on just some of the general things about starting a business. Forget even the product. Trey Stevens recently talked about this of they had basically 10 years of experience at Palantir, and they had a lot of lessons learned that they didn't have to relearn at Anduril that I sort of took for granted. They also were kind of first movers in their thesis, and Palmer talks about this a lot of how at the time it was not a popular investment. It was, still looked down upon. But what you had was a core constituency of employees who were either people coming from the Palantir orbit, so they were already kind of aligned to this mission through that vertical, or veterans. And so I was a part of a very large, veteran community that was coming out of the GWAT, the Global War on Terrorism era. And we were thrilled to see, smart engineers, young people, private capital working on these problems. And we wanted to just participate. And so you had a level of energy and motivation that was just otherworldly. And we worked on, I think, some of the correct problems at the correct time. And being first in market, interest rates were different, the multiples were different. We certainly had headwinds, but as we succeeded, there was nobody else like us. And so, yeah, for me, it was incredibly formative, and I'm super grateful to have been in the right place at the right time.
What then drew you over to Hermeus?
Yeah, so one of the lessons that I think I took away from Anduril was, how do you go to market as a new entrant, and how intertwined the primes are with the sort of acquisition system and then that ecosystem. It's not a market in the traditional sense where value attrits to where it's created. It's very constrained, right? The budget is set by Congress, not by Keynesian economics. So it's clear that the preponderance of the Defense Department's budget is driven by integrated heavy systems, fighter jets, ships, tanks, large missiles, satellites, things like that. They overwhelmingly sort of consume the non-personnel budget of the Pentagon. And if you want to break through, you have to work on those programs. And it was very clear to Anduril as I was leaving that Anduril was moving into more of that space, getting out of just software, just low cost hardware. You have to get into things that are not as exquisite as an F-47, but just have some heft to them. And what I liked about Hermeus was that was the entire modus operandi of the business, to go after a problem of that scale and scope from the start. And it is very risky, to be sure, but it is also so impactful that when it works, it's kind of beyond reproach of its adoptability or its applicability. And so, we've had a pretty decent amount of success to date with that thesis. And I just wanted to take a shot to kind of just go straight for what I thought the heart of the problem was.
Cool. And so when did you join Hermeus in their life cycle?
It was 23. So I think I was employed somewhere 65 to 70.
Okay. And how big are they now?
We're a little under 300.
Perfect. So for those that don't know, what is the mission of Hermeus and where are you in this life cycle journey to achieve this mission?
No, that's a great question. I think there's been a little bit of confusion about this because as the business was first formed and we were going to market, kind of trying to thread multiple needles. And to be very clear, Hermeus is a defense technology company, and we are focused on building fast airplanes fast, right? The impact of low observable systems is eroding. The cost of low observable systems is increasing, and speed is sort of one of the ways that you can get after some of these problems in an affordable way. In the 60s, in particular, the United States was heavily involved in high-speed system development, and the creation of intercontinental ballistic missiles and the creation of stealth technologies, no pun intended, decelerated that. So for Hermeus, as a defense technology provider, we want to bring back fast aircraft development of fast aircraft. And that is solely what we're performing on. To the degree that that applies to commercial technologies in the future, absolutely, we're not writing that off. But our end market, our customer is the Department of Defense and allied partner nations, and building unmanned systems that can fly high and fast in sort of pursuit of national security.
And so Hermeus, when was it founded and kind of where are, what are some key milestones? Where are
Yeah, so I think there's, three sort of key milestones that I'd point to. So one is we proved our core propulsion architecture on the ground, which is something called the turbine-based combined cycle engine. We didn't invent this. This is, again, relatively old technology. NASA had started the work on this. DARPA has done this in the past, and they demonstrated the turbine-based combined cycle engine. Spent about, 9 figures on it. We did it in 2022 and spent about $20 million on it, demonstrating the interplay between a turbojet engine and a ramjet. So you can go from 0 to Mach 5, right? So we did that in the wind tunnel. We're the only private company that's done that completely without, the government. And that is what's required to fly Mach 5. Now, we haven't done that in the air yet, and we haven't done it with our core turbine engine, which is the F100 229, but we have proven the architecture on the ground. The next thing was last year, we flew our first aircraft, a 10,000-pound unmanned aircraft out of Edwards. And the purpose of that aircraft was a couple things. Number one, demonstrate that you could build a jet aircraft. I mean, building a jet aircraft is not nothing. It's a 10,000-pound aircraft, size of like an F5 trainer. And it was a GE-85 engine, 4 compass, remotely piloted, all the things that go into that. And we did that. And it was 15 months from design, build, test, and ready to fly. We got sideways, the lake bed got wet, and then you got to just wait. But the plane was ready to fly, and from the first, pen on paper to flight in 15 months. And that's incredibly fast for a 10,000-pound airplane. And then also demonstrating the high-speed takeoff and landing for like a very fast outer mold line, a very fast shape, right? If you're going to fly high and fast, you got to have sort of the pointy shape of the aircraft, but you can't have huge wings that allow you to take off easy with a lot of lift, but it's going to create all that drag. So we validated the outer mold line shape with that aircraft. And then now we are about to fly here, hopefully later this quarter, we're on track, our first supersonic aircraft. So this aircraft is a Mark II. It is a 30,000-pound aircraft. It's powered by Pratt & Whitney's F100 229, which is the F-16, F-15 power plant. This vehicle will fly out of White Sands in Spaceport America out in New Mexico. And that will get us into what I would consider like the first sort of productizable opportunity for the business, which is to say that the vehicle we flew before was truly a test article, not real utility to anybody. This vehicle, once we use it for our own purposes, has a lot of utility in the exercise cycles. We're going to be integrating other systems onto it. It's got power. It's got some payload capacity. And so now, I think 26 is the year that you're really going to see Hermeus flying large aircraft high and fast.
That's cool. And for listeners that don't know, talk to me just what's the difference? What is hypersonic?
Yeah. So hypersonic is an arbitrary number somebody somewhere made up that's Mach 5. So if you're Mach 4.9, you're not hypersonic. If you're Mach 5, you're hypersonic. Now, does that really matter? Honestly, no, but that's where the line is drawn, and that is where we are going. We are designing our Dark Horse aircraft to be a low Mach 5 platform, and that is something we see coming together before the end of the decade.
So you're focused on unmanned, right? No manned.
Yeah.
And kind of intermittent use cases. So like the Mark II, just for my time flying, could be a cool adversary threat emulator, if you will, or not even an emulator, just like a threat aircraft to fly against. Is that part of your thesis to take that to the government?
I mean, yes. So the way I describe this platform is it's sort of like a stack of ands, right? And this, and this, and this. So if you have an unmanned F-16 that can ultimately get up to like a Mach 3 capability. What do you want to do with it? There's a wide range of use cases for it, right? It could be an electronic attack, electronic warfare platform. It could just be an unmanned F-16 with a ton of rails on it, right? It's not low observable, but there's plenty of missions for the 4th gen fighters that are still very applicable. It could be a red air system. It could be a target. And then there's some other use cases in the higher speed regime that we're working on as well. So, I mean, there is nothing else in the market that is going to give you the range payload of something like this. All the other unmanned systems are just in a totally different class in terms of size, thrust, and payload capacity. And so, it's sometimes hard because they're like, well, what do you want to do with it? I'm like, I mean, what do you want to do with it? It's an end of kind of infinite from a creativity standpoint, and the applicability is pretty broad. Our thesis in part is once the vehicle starts flying and you have this first product and people can start taking what they imagine and experimenting with it, that will unwrap a lot of opportunity for it. So our focus really in 2026 is to get, we're building 3 of these tails, get these tails out into the world, start flying them. And then for engineers, I can't think of a better place if you're a hardware engineer to work. I don't know where else in the market you can find an opportunity to work on high speed, unmanned, integrated heavy hardware, right? It's basically SpaceX. That's it. There's nowhere else that's doing large high speed systems that are this complex and integrated in the market anywhere, period. And so the pace that we're working at is also drawing a lot of talent to continue to help us build out and experiment with these types of technologies.
So in the competitive landscape, is there anyone else doing? I mean, we've got other hypersonic, and else ones that come to mind like Boom, and there's some of these others that are more manned. You've got hypersonics that exist within the primes for weapons. Where does your competition sit with you right now?
Yeah, I mean, there's nobody sort of competing in our specific lane. So Boom is just a supersonic, aircraft provider, right? So you're Mach 1 plus, and it's all commercial, right? They have to design and build and certify a new commercial engine. They have to design, build, and certify a new commercial airframe. Totally different problem space. On the primes, to your point, they're working weapons. Those are all sort of rocket based, and the principle that we're applying here is to get into the world of reusability, we wanted to do something more air breathing, right? So we are an air breathing system. There's nobody really doing air breathers anywhere. There's certainly nobody doing aircraft yet. Everybody to either doing aircraft is just design. Nobody's bending metal or building or flying. I mean, we're firing engines, we're building airframes, and we're going to start flying things, we've been flying in last year, but we're going to start flying this next fleet of aircraft right now. And so we haven't seen anybody, in our lane yet. There are people doing portions of it. You've got some people working on engine things, parts of engines. Some people have, renders for rocket planes and things like that. But I'm not aware of anybody else bending integrated metal or firing engines that are coupled to the airframes. Because let's be very clear, when you're building high-speed aircraft or even any high-speed system, the propulsion system and the airframe are very integrated. So, if you were to buy a off-the-shelf hypersonic air-breathing engine, you're going to be kind of constrained on what your design for your aircraft's going to look like. The engine's going to kind of put you in certain situations for the inlet and other things that are going to tell you what your design has to be. And so this is also where we've taken a very vertical approach of like a propulsion system, as much as we can. I mean, it's the F-100 229 and some other things we do to it, but integrating that so that we can design them together. So no, long answer here, there is not anybody that we're aware of that is as integrated and in pursuit of flight operations at this pace that we are.
How about like adversaries? Anyone doing that you're aware of?
Yeah, I mean, the Chinese are certainly doing a lot. I mean, the biggest thing is they test on literally an order of magnitude more than we do. They are out there testing constantly. And, we can't really get into the things they're doing, but they're doing a lot. And I would say that, certainly publicly discussed, you see in the GAO reports on the missile side, they're definitely ahead. On the aircraft side, coin is up. Nobody's really won that yet, sort of open field. But like, they're certainly not behind, right? Just given the pace of testing, even on the weapon side, because there's just so much learning that comes with all these systems, even if they're not apples to apples. And the Russians, certainly with like the Kinzhal and other systems have deployed things as well. I think one of the things that's tricky that people need to remember though is hypersonics. When you talk about hypersonics, it's Mach 5. There are a lot of systems that are technically hypersonic, and ICBM, the reentry vehicle, is hypersonic, right? They certainly a spaceship when it enters hypersonic. What we're really talking about is the ability to maneuver at those speeds. And that is what gets things very complicated. And, there is a lot of sort of misinformation and classified information about who's out there, but it's really the Chinese, the Russians, and us. And I don't think anybody has sort of crossed the finish line yet, but I would say from my view, like the Chinese are probably the furthest ahead. We are doing better, but we haven't fielded anything at scale yet in the hypersonics realm. All of our programs are still, tests and RDT&E.
Yeah, so that's great. What are the big technological hurdles, and why is this so hard?
Yeah, great question. There's a lot. I actually think, there's a way to decompose the problem, which is to say, how hard do you want to make it? So there's a definite, it's hard to get to Mach 5, period. It's even harder to get to Mach 6, and it's asymmetric. It's not as equal, it's not equally as hard to go up. You start getting above Mach 5.5-ish, and you start getting into Mach 6, you're in a different propulsion system. You're in a scramjet configuration. You need materials that don't necessarily exist at scale, CMCs, these carbon fiber, high-speed skins, right, that are not mass producible. You see this certainly with Elon and the reentry vehicles making tiles, right, putting onto the spaceships that come back in. So your problem starts to run away from you as you get even faster and faster and faster. The cost becomes greater, and the size of the vehicle becomes greater, and it reinforces this loop of complexity. Our view has been make the hard problem as simple as possible. So above Mach 5 in the low Mach 5 regime, you're as survivable roughly as you would be a little bit faster, Mach 6-ish. But if you wanted to squeeze out that extra Mach, the complexity cost, the timing cost it's just huge. It's so much bigger. So I think, the challenges then become long duration thermal management of the aircraft. But at Mach 5, you can do a hot airframe. So you can do titanium and Inconel, which are mass producible, versus a CMC. The propulsion system is simpler. There's some contention around what's the right way to do this with a turbine-based combined cycle engine. Do you use a pre-cooler to cool the air in front of the turbine? Do you use a high Mach gas turbine that doesn't exist, in which case you kind of have the boom problem where you have to build an entirely new turbine engine? We didn't want to do that. That adds a whole nother challenge. We wanted to kind of hack that. And then I think the bigger challenge is economic pace. This costs money. It's an engineering problem, right? It's not really a science problem. It's an engineering problem. And engineering requires consistent funding so you can work, and then consistent testing. And to your question you asked about adversaries, the United States testing is very challenging. I mean, we're looking at going to Australia to be able to test, because really what you want to be able to do is say, hey, all right, I think we're in a good spot. Let's go test tomorrow. Great. Let's go just pull the plane out, fly it. Instead, what you have to do is you have to schedule your range time and kind of call your shot. And it's an R&D program. So you're I might miss that by weather. I could miss it on just a short circuit. It doesn't matter. And then I missed my window for test. It takes another month. I had to pay for that range time. I'm down for a month just on nonsense, and the business is sort of bleeding out. And so these are some of the challenges that I think are even bigger than the technical challenges of getting there, is the ability to focus on the hard things and just build and fly versus, okay, we got to build a company. We got to build a team. I got to keep the lights on. I got to pace the economics. I got to maintain the talent. And all those things kind of converge into the problem set. And by the way, along the way, I don't necessarily have a product yet, right? I'm building and demonstrating and testing. And how quickly can I do that so that I can unlock further capital to continue on that journey?
So if we talk then about, the acquisition, I mean, this is, you said it's a DOW initiative. You're trying to build defense tech, or you are building defense tech. Who are you working with? What are the challenges? And do you see a path forward?
Yeah.
Where you're going to be successful, and we can unlock, remove these blockers from companies like yours that are trying to do really cool things.
Yeah, I mean, I think we have a big role in our own success, which is we got to demonstrate incremental success. So going supersonic and continue to increase the speed regime to give confidence to the DOW and the decision makers there to make a bet on us. You can't go in there with a PowerPoint working on what we're working on and ask for a program of record. That's obscene. So our relationship right now, we're really close with DIU. That's kind of been our core entry point, and I think they've been a really great partner for us, and been really grateful to the work that DOW has done there, to the work that Chairman Calvert has done on the Hill to put an emphasis there. It's a challenge because if you're building a heavy system, right, like we are, the historic way that those technologies, and I'll use the Air Force, are innovated and brought to market being the DoD, is through the S&T community, the science and technology community, the labs and the DARPAs. So the labs are part of the services. The Air Force Research Lab is under the Air Force's, TOA, and DARPA is a part of the R&E, the OSW, research and engineering kind of horizontal piece across the top. And so if it's a DARPA initiative, then they will eventually work with the services to transition it. Be like, okay, we built this prototype. Now you guys have to budget money to purchase this product. If it's coming through, and that DIU is the same. DIU, right, is working in the OSW layer, not in the service layer. There's a real challenge, I believe, going through the services, because the labs oftentimes are your competitors. They have a different, if they have a different approach to your problem and they don't want to work with you, that's it. You cannot do R&D work with the service now. That's it. It is a binary. Like, you are not welcome here, and there is no hedge. And so what you don't really see, in my view, is a lot of diversity of thought or approach. And so, you see defense tech and it looks very software heavy and it looks very attritable system heavy. And that's in part because it's very hard to do co-development, R&D co-development at scale with the services, because they have deep relationships with the primes. They pay the primes. That's why they're called contractors, right? Just like your house, your contractor gets a scheme, an architecture drawing from the architect, and they build it. The labs are very similar. They work with the Lockheeds and the Boeings with a schema. They are the architects of this concept. They contract it out to the company to build their vision, and then it gets built. So when you come in with a different vision, if they're not aligned to it, they might not be willing to take that trip with you. Whereas DIU and some of the more commercially minded companies are like, okay, we'll explore this. We don't necessarily have a preconceived notion here. I mean, this goes to things that DIU's talked about in the past of being a hedge, right, against other acquisition pathways. And so, we've got a lot of great relationships with the Air Force and the service and parts of AFRL, don't get me wrong, but it is a much harder entry point for a non-traditional to kind of go through the S&T vertical with an idea that maybe is novel or new or risky versus a traditional approach.
Yeah, it's interesting. You're competing against them. So obviously capital is an issue. How much have you guys raised, if you can share it, or if you don't mind sharing it? And because that is the advantage versus a Lockheed, for example, is just getting contracted. They're not putting their own dollars behind it. And how sustainable is that? Because at some point, investors, are going to want a return. And if you've got this risk over here, and it's all that risk balance, and just kind of talk me through, the financing behind it.
I'll say we've raised in the hundreds of millions, and it's good. We certainly have to continue to develop and deliver. I think it's, the investors are correctly looking for some level of interest and partnership from the department, not even to say we need a program of record, but like, hey, we, the investors, are pouring money into this. Is there interest there? Do we want to keep going together? And it's kind of like our turn, your turn, our turn, your turn, right? The investors put something in, we develop something, the department partners up. This is really interesting. We want to experiment. Here's a contract, not a program of record, but here we're going to do some work with it. The investors go, okay, that was good. There's more there. We're going to continue this sort of symbiosis, which is typically like a 3-to-1, private capital, $1 of public capital, if you will. On the prime side, you're right. They don't spend IRAD R&D money the same way, but they don't necessarily need to, because they get large R&D contracts. So they're not incentivized to do that. So like, a prime isn't necessarily going to go out and spend hundreds of millions of dollars pursuing a technology set that they don't have high conviction is going to have a program of record at the end of it, right? Like, they can't go borrow money or raise capital. They're not structured that way. The expectation is you will get an R&D contract. You will have a cost plus a contract that gives you a set margin on that. And then you'll do it as long as it takes. The longer you go, the more profit you make, right? Because your margin is fixed. And so there's not an incentive structure for that. And the R&D contracts continue to be cut in that way. And so I think what you're seeing is a lot more maturity in terms of procurement contracting. But what I don't think you're seeing as much yet is the maturity and innovation or disruption on the R&D contracting.
Interesting. Do you see a path forward? I mean, what's your strategy to break into this, to get them to, is there a change afoot, or?
Yeah, there's definitely change afoot. I mean, this is a generational opportunity with this DOW, period, full stop. The secretary, his team, the OSW team, the deputy, the president, Congress, like, they're there, the services. I mean, I think you've seen, the Army chief, the Navy chief, you're beginning to see the Air Force, like, the ship is turning. I do think we have a responsibility as an innovator in the space to be successful. I mean, if I'm going to say, we want to participate, I need to fly planes. I need to demonstrate something. I need to show that I am delivering on my rhetoric. And so this is a big year for us. I do think there is a path to success. I do think it's going to be clunky. We do have a strategy. I'm not going to, detail it here, but the easiest way to think of it is do what you say you're going to do. It's not really that complicated. And if you're not, be very clear about what happened. Don't be defensive. There are reasons that we've been delayed that have been fully on us. Fully on us. There are reasons we've been delayed that have been fully on the Pentagon. And we don't want it to be an adversarial thing. We actually all want the same thing. It's the beauty of this sort of market is everybody's actually very interested in the same outcome. You're just bringing different lessons learned and approaches, but nobody has like a disagreement on like supporting the warfighter or, making sure that the American military machine is the preeminent global power. we get caught up in, the approach. And so I am hopeful. I think we also know, and just seeing what the areas of focus are for the department, that hypersonics, and specifically scaled hypersonics, or like affordable hypersonics, is a big area of focus. And that requires new entrants. I mean, another company that's doing a great job in this space that we admire tremendously and are good friends with is Castilian, doing hypersonic missiles. And that's a brilliant team. And we talk to them a lot, just comparing notes and their approach. And they have done a great job of saying they're going to do a thing and then doing a thing. And then that creates this sort of symbiotic relationship, and the service showing up to be like, hey, we want to partner here. We're working with the Air Force. We're very tied in with the senior leaders in the service to do something similar as we demonstrate more capability.
Yeah, that's great. Have you, so coming from Anduril, I talked with Anduril. They had a unique way with Ghost Shark, I believe it was.
Yeah,
They partnered with with Australia. And so there was joint buy-in to deliver. Have you guys looked at that? What's your thoughts on that, that kind of idea?
Yeah, I mean, we talked to the allies. I think this is a technical space that's a little bit more complex than Ghost Shark. Submarines are well understood in how they support the battlefield, and Ghost Shark is a less expensive system than an unmanned high altitude, high Mach aircraft. And so it's a little bit more complex, but I do think there is a huge opportunity, especially under the AUKUS Pillar 2 pathway, to do co-development and to do employment of these systems. I also think at the time, I was leaving Anduril right around the time that was working. Anduril, you really have to have a very strong go-to-market motion and have good capital access, right? So Anduril matched that funding. So,
Right.
The Australians put in 75 million, and then Anduril and their investors put in another 75 million. And so it's like, okay, if I'm going to go to my investors, to leverage that, I need to have my product in a more mature state. I need to have other things. Anduril had other products that were also floating the business. They had acquired a Dive that had built out some of these things. So it is a pathway, but I think for us, we have to get more mature before we look at that. But there's no doubt that there's use there. And there's another question too for us is the world is also different right now. Maybe not as much with Australia, but if you look at Europe with the relationship with NATO and how the Europeans are thinking about establishing native European technologies and the degree to which they even want to work with American companies. Certainly if you go over there, you really need to be partnered directly with an onshore manufacturer, which frankly is not a big deal. We're happy to partner with Imitol and everything like that. We'd probably do something similar in Australia. But the geopolitical dynamics right now are different. And so we are just really focused at this moment of demonstrating the technology that we've been discussing for the last year, and then taking what we've demonstrated and now saying, okay, given what we've shown, is there an appetite to employ this, to integrate this into your service, to experiment with it? Versus Dive is hey, we know how submarines work. We want to see you manufacture as a 3D printing approach and the integration approach. But what we need to do is prove that submarine works first. That's sort of where we're at in this.
Yeah, no, that makes sense. That makes a lot of sense. Interesting. So let's go back a little bit more to what makes you guys unique. You're talking about make big things go fast, really fast. What is kind of your secret sauce? Why are you think uniquely aligned or empowered to do this?
Yeah, I mean, I think it's kind of a cliche, but it's the people, right? The key to this business is people. Ultimately, America used to know how to do this. The SR-71 flew in the 60s. We brain dumped all of this. And so we're having to kind of relearn it. And you can't go out and hire Kelly Johnson. Kelly Johnson's gone. And that talent pool from him is aged out and gone. And so you really have to recreate that human capital. And so we have been very specific and particular about who we brought into the team and the way we approach, the kind of Elon, the best part is no part, very heavy first principles, very much stripping it down to what does it absolutely need to do, being hardware rich, right? The idea that you're going to build the Mach 5 aircraft as your first aircraft is absurd. You're never going to get there. These are how the current programs run away, how the F-35 runs away, and you never actually get there. And so taking a very hardware rich approach, high iteration, has been sort of the key. And that also allows you to develop your team along the way, right? So we talked about the first aircraft. Maybe I didn't really mention it, but I think it's really important to go back is that aircraft was also about the team working together. That team had never built an airplane before. And if you go to find okay, I want to hire somebody who's got experience in aircraft programs, pretty much everybody, best case, has done one aircraft program. The F-35 is a multi-decade program. The F-22 multi-decade program. And the F-16, F-15 programs are now just the block upgrades and the production. The design phase was in the 70s. And so there's very few, if any, people who have a clean sheet design experience on multiple airframes. It's not a thing really anymore. It used to be a thing, and again, in the 60s and 70s, Dassault had done this, we had done this, and so we had to really go and find the talent that had clean sheet integrated heavy system hardware, clean sheet design experience. So a lot of people from like SpaceX as an example was best case, and then take that talent, start applying it to aviation. And as we go forward, our view is if you want to build an aircraft company in 5-10 years, if you're not hiring somebody who's worked at Anduril, like you're doing it wrong. Just the way you talk about, for rockets, you probably want somebody who's at least been a part of the SpaceX ecosystem. And so I think that has been our special sauce is our talent. And then applying that talent to a very specific, high iteration, first principles approach on bending metal and flying as quickly as possible.
Yeah, I mean, I think you bring up a great point of we stopped trying to pursue, objectives that you're doing, just like heavy lift in the space, that we just stopped that and outsourced it. Also, it's like, oh my God, had we not had SpaceX, we would be screwed.
Exactly. A lot of the SR-71 documentation that was in the agency was on paper, and nobody knows where it went. Files are not in the computer.
JFK files. That's what them. They're buried in the National Treasure President's Only Club.
We need to call Nick Cage. We'll find him.
Perfect. When you're building, I mean, one of this, I would think, talking to a lot of companies, there's the prototype phase and there's scaling. Are you building in scalable? I mean, is that part of your design solution to make sure that you could go into full production?
Yeah, absolutely. I mean, you got to think about scalability in production. So some of the things we've adopted in terms of like, how do we think about that is, for starters, like using the F-100 229. I'm not going to build a brand new turbine engine. So like, we've already talked to Pratt about how do we scale production. We know how to scale production with them. Their supply chain there, like there's a lot there. You can do that. Picking our material suppliers, right? And simple manufacturing processes. So like nobody's really building metal airframes these days. We're building full metal airframes with metal skins, aluminum skins, and then eventually steel and the higher temp capabilities. But being able to take off every single panel on the airplane, getting into a modular design. So I can pop the inlet with a handful of bolts and go from a pitot inlet to a spike inlet. I could pop the wings off with a couple bolts and go from a high delta wing config to like more of an F-16 config, which would be better for maybe a low supersonic aircraft that you want to have more payload on, right? And so making things as simple as possible. I mean, our engineers joke, it's like the flow path, straight line. It's a flying tube, right? We love tubes, and keeping things simple. That then lends itself to not only manufacturability, but maintenance, upgrades, things like that. And so, yeah, we have been very thoughtful about that by default in how we build the plane, because if you build in complexity in design and prototyping, it's going to follow you through the whole life cycle of the aircraft, for sure. One of the big long leads for us is going to be welders in some of the systems, right? Kind of like SpaceX, and just keeping things very simple. And like, if you were to look at some of our core designs, the inlet, the leading edges, the landing gear, the propulsion, we're stealing known things. The NASA 4060 inlet, reams of data public, the F-16 engine, the F-16 landing gear, the MiG fuselage, the SR-71 leading edge, right? Like I'm not trying to start from scratch where I know things already and I can apply them. And that, again, all lends itself down the life cycle to easier integration, easier manufacturing, easier supply chain, easier sustainment.
Yeah, that makes a lot of sense. Well, your engine, your 229, that's not going to be the hypersonic engine, is it?
So the way the engine works is, and the challenge with turbine-based combined cycles is, ramjets only really start working at around Mach 3. And it's no moving parts in a ramjet. It's fuel, it's pressure. The challenge is, how do you get to Mach 3? Turbine engines don't go to Mach 3. So historically, you use a rocket. The rocket gets you up to Mach 3. And then you can light the ramjet once you're at Mach 3. But then you're on cruise. But now you can't decelerate, because once you're under Mach 3, the thing's got to kind of glide down or go terminal. So what we do in the turbine-based combined cycle is we have proprietary technology that allows us to effectively, what I like to, too fast, too furious, the 229, and we can get onto Mach 3 condition for 90 seconds or so. And at that point, I have the turbine engine in line with the ramjet. We lop off the afterburner. We put on something called the ram burner, which is an afterburner / ramjet. And once it's Mach 3, you light the ramjet, and I cocoon the turbine engine, and I route the air around the turbine engine directly to the ramjet. And now I'm flying Mach 3 to about Mach 5. And then when I decelerate, I do that in reverse. I open the doors, the airflow goes straight through the turbine engine. I light the turbine engine back up, and I come down from Mach 3 down to 0. And this is how you can get that Mach 3 to 0 up and down with the reusability. but you have to do some of the proprietary things to the engine with the 229 that we're doing. And Raytheon is an investor, so we have a really good relationship with Pratt & Whitney to do some of the modifications to allow that engine to operate in those conditions.
Okay, so the 229 is
It's the core propulsion plant for the turbine part of the cycle, but then the ramjet will take you from Mach 3 up.
and so you have in testing with that motor and your whole combined, propulsion system, you have shown the ability to get up and down.
So what we have done is with a GEJ85, we have demonstrated the up and down. So we have proven the architecture, the doors, the routing, the ramjet. With the 229, we have proven Mach 3 in a tunnel, but we haven't attached the ramjet yet. We'll do that next, but we know the architecture works, right? Like we proved the architecture. So it's just doing it with a bigger engine, with bigger, higher airflow and all those things. So not saying, oh, it's easy, it's going to just happen, but we've taken a ton of the risk off. And this is again, back to the SpaceX approach. If you're going to do these high risk learning iterations, do it on the smaller, less expensive engine, because if it doesn't work or things break, it broke on the less expensive, smaller system. It works, you take all those applications that you learned from, and now you bring it up to the more expensive system. And so we've proven the architecture, like I said, and we'll now apply it to the full 229 engine and full size ramjet.
Yeah, that makes a ton of sense. Yeah, so I imagine this supersonic, just from a business case, having that and having customers interested would really change, your ability to access to capital.
Yeah, I think so. I mean, that's sort of our assumption. And we've also been sort of strategically quiet. We don't do a lot of podcasts. We haven't really done a lot of comms in the last year or so, as we've been really heads down trying to get this business, get these aircraft built. And now, and I think it's, it's the smart thing to do when you're doing the hard work, just shut up and do the work, right? Like I really don't want to talk about it. I got a lot of work to do. And like, it's already a very bold claim and a bold conversation. So I'd rather say less and do more. And so now that the first aircraft, the first high-speed aircraft is at White Sands, the second aircraft is on the stand being built, we're ready to start talking and ready to start showing what we're doing and ready to start really being like, hey, here we are. And, we believe, we've got some contracts in the hopper that will come to fruition with what you described. But it's all on us. I mean, we have to live up to what we're saying here. And I think oftentimes some, people can be a little bit, their expectations can be not aligned to reality, which is you got to do it too. You got to actually execute.
Yeah, absolutely. I mean, you just got to get the hard work done. And
no shortcuts.
Stop selling vision. That was great to get you your initial capital, but now you got to go.
You got to go. Yep.
Well, thanks for then podcasting with me. I didn't realize we're on a podcast hold. Maybe that's why it's so hard. It has been so hard to get you on.
Yeah. We've been very quiet. Your timing's good.
Fantastic. All right. Yeah, we're gonna have to slowly start rolling this out. I've got like kind of lightning round questions. They're generally broader, and you may have already answered it. Just give me 30-second, minute, whatever it is. We'll just move on to the next one. Not a lot of commentary from me on it. So, what's the biggest misconception about selling to DoW?
That the warfighter is your customer. The warfighter is not your customer. The warfighter is your end user. The customer is the acquisition official, the requirements official. They are very different. You need to understand that.
Perfect. What's the hardest lesson you've learned while helping build and grow defense companies, Anduril and Hermeus?
You do not have enough time.
Number one piece of advice you'd give to other leaders that are trying to build defense tech companies?
Yeah. Stop following other people's ideas. There's too many quadcopter companies. There's too many like command and control companies. You really need to be thinking about building technology that will actually make a difference and is unique. And also, this is not a market, right? This is not a market like the smartphone market that had no dollars of spend in it the day before the smartphone existed and then became a multi-$100 billion marketplace. This is a monopsony that is highly political and is typically very zero sum. In order for you to get $1, I potentially have to lose $1, which means you're going to not only put a product into the market that's going to create value, but it's going to consume from somebody else who's trying to create value. So you really need to have something that is clearly differentiated, and being good is not good enough. You have to be an order of magnitude better to pull $1 out of somebody else's pocket to put it in your own.
Name a sacred cow in defense tech that you think will be proven false.
Software is a combat enabler, but it is not the be all end all. And so what I mean by that is you need it to go faster to accelerate outcomes, but hardware kills the enemy, not software. And so like, I think sometimes we lose sight of the significance of hardware at the expense of software. And I think sometimes we try and talk about one or the other having a primacy role, but I think you just got to understand that software ultimately can only deliver effects through hardware and can only consume information through hardware. It has to have a sensor to import information, and it has to have an effector to export an outcome. And so I do think we just need to be careful on sometimes the obsession that software will win a war. Software will enable us to go faster, but hardware wins wars.
And what do you think the biggest opportunity is in defense right now?
Integrated systems are really where you're going to see the most opportunity. It's the hardest part of the market, but typically the hardest part of the market is where the most opportunity is. So if you see the challenges that the Navy's had with building ships, some of the success a company like Supersonic has had, Anduril is getting into this space. They've been in the space with Dive. You see what's happening with the CCA program, aircraft. That is where I believe the real value is. And this goes to my previous point of software has a huge role to play, no question. But the real value is an integrated hardware. And if you look at if you were to actually do the budget analysis, which is the thing I used to have to do in my pre-Anduril days, and you look at the way the budget is structured and where the dollars actually flow, it flows to heavy hardware. And I don't just mean the F-35 and the F-47 and the F-15, but like it is metal. It is large end items or larger end items. Quadcopters have a role. Quadcopters in these FPV drones are effectively smart ammunition and should be treated that way. They're going to be purchased and employed like ammunition. But if we use the Ukraine model, like the entire U.S. military is built to avoid a trench war. Like we are trying to overmatch people so that we don't end up in World War I or Ukraine. And if there was air superiority in Ukraine in either direction, you would not see the front line static the way it is. And so I think this goes back to like the opportunity in the DoD is demonstrating scalable unmanned systems that can give you the range, payload, and impact that you would find in some of these larger systems. And it may be a specific example like HIMARS. HIMARS is an incredible system, falls into my heavy system category. If you want to replace HIMARS and disaggregate and say, oh, I'm going to do it with unmanned systems, like, okay, well, then you need to be able to provide at least the cost of a HIMARS, the same range and payload that the HIMARS can provide, right? So if you disaggregate the HIMARS into 1,000 quadcopters, but the quadcopters can only cover 30 kilometers, you didn't do it, right? And so these are all like big integrated heavy systems that really drive the warfighting function. And so that to me is where the opportunities. This has actually been callback to Castilian. Castilian, right? One of the things they're working on is a longer range, lower cost hypersonic missile to go into like a HIMARS type container. That is disruptive. That helps that integrated system be more lethal. So that to me is where the opportunity in the DOW is now and going forward.
Very cool. Well, that wraps it up. Unfortunately, I'd love to keep chatting with you. Maybe when I get out to DC, I'll go buy a beer. We can
Yeah, I always love a beer.
hang out. But thanks so much. If people want to follow what you're doing, get updates on your, soon to be test flight, which I'm excited for, how would they do that?
Yeah, I mean, the easiest thing is follow us on Twitter, follow us on LinkedIn, just Hermeus. And yeah, we post all that information up there in the public as it comes out. I think you'll start seeing a lot more content from us now as the aircraft, like I said, are getting out into the field and we really are ready to start talking about it and showing off what we've been working on.
Awesome. Well, thanks so much, Zach, and we'll be in touch.
All right. Thanks, David.